So then the main part really of this presentation is really a demo of the tools that we made for validating things like variable names, model names, scenario names, and so on, and to do vetting of various types. Not everything is finished there, but it's ready for test use. The main tool is a web-based tool. At the moment, it can be downloaded and run locally if you want to. That's the top URL there, which I'll show in a minute. We've also made a few underlying software packages. Those are the two next URLs. There's the IAM COMPACT nomenclature, which contains harmonized names of various sorts and region maps. Not entirely complete, and there are some things we still need to discuss there. So we had a discussion before the summer that kind of stalled for various reasons, but we need to complete that discussion. And then another package called IAM COMPACT Vetting that contains software that you can use to assess, do various types of vetting, assess how your data fits with different kinds of criteria, where you can easily add, for example, the AR6 vetting criteria are there. It should be fairly easy to add the AR7 criteria when they come, unless they're totally crazy. And also that lets you compare different time series so that you can then, if you have like a harmonization time series of population data, for example, which we have here, then you can compare that to your own data and get out in a nice format how much it deviates in max and how much it deviates for each year and each time series. So I'll show that in a moment. We also built on some third-party libraries, mostly from the IAMC, so the nomenclature repository that some of you might be familiar with, and the companion common definitions repository. They're made for assessing naming conventions and defining naming conventions. But I'll just move on here to the main demo itself. So my apologies if this is a bit small to see online. I'll see if I can just make it one. Yeah, I can make it bigger, but the resolution on the screen here isn't all that great. There, okay, so this is the GitHub repository that I linked to earlier. What you can do if you want to run this now offline, which you can do right afterwards if you want to, or you can wait for it to come up on the I2AM Paris platform later on. But to run it locally, you can clone this repository if you know how to do that or are familiar with doing that. Set up a virtual Python environment and install some dependencies. So there's I haven't included a primer on how to set up Python environments there, but if you know how to set up a virtual Python environment, you should be able to use these instructions to install this package and run the app. And then you go to a local URL on your computer and start it from there. If you prefer to use Docker, there's also a Docker file that you can use to do the same thing without having to set up any extra environments or install any extra libraries. But then you need to be able to compile a Docker file and start a Docker container. If you need help with any of that and you don't want to wait for the web app to hit the cloud, then just talk to me, and I can also assist you with steps for actually setting up a Python environment where you can do this.
If that's done, we can directly update the platform version, right? So it's a new version basically, right? So we need to just update IAM Paris.
Yeah, that's right.
If you're ready, you can talk directly with us and George, and we can.
Yeah. There's a Docker file ready that just needs to be pushed. But there will probably also be, several updates over the coming few weeks as we work out the naming conventions and so on. There also isn't a full set of harmonization data that's included as of right now, so I'm just going to show it with the population and GDP data right now. The emissions data will also be in there soon. The energy data are a little more tricky just because of the IEA, but I have a potential solution for that as well. Okay, so then I've already followed the instructions here. So if you then go to, if you then start it on your computer, you get and go to the URL that's listed in the README. You get to a page like this. You can also do the same things that I'm showing here, sort of more manually using the underlying Python packages, but I think this is probably going to be the most convenient way to do it. So then, there's a limit of 50 megabytes. I'm going to make that a bit bigger because I think some of you might have bigger files than that. So the data that I'm going to demo this with is from the first modeling cycle, and this is actually an old uploaded results from many months ago. I saw that new output has now been uploaded to the SharePoint and to Zenodo just a few days ago, but I didn't have time to compile that into a single file. So this is older data, but that also lets me highlight a few issues that might have been fixed with the with the new data, just to show you sort of what happens when there are things that might need to be corrected. So then you upload that. It's assuming it's in valid IAMC format, it then parses that and loads it there. Once that's loaded, so there's a function here that lets you inspect the data, but often there will be many thousands of rows, so you might not want to do that, but at least you can check that it's the right file and that which years are included. Now here there are several models in the same file, so you have none or empty for some years for some models. But once you've done that, and also on the left here, on the first page, there's a set of instructions, rather detailed instructions about how your file needs to be formatted, which might also be useful to read if the upload fails for some reason. And then there's a list of pages here that you should step through one by one. So first, there's validating names. So then it says that, okay, you haven't run name validation yet, so no point in proceeding to the next pages. So just do that, and it basically checks different naming conventions in the file. Region names takes the longest because it's and then, oh my God, terrible. Yeah, no, actually, the first time you run this, you should expect to get a red X on all of these things, basically, because if there's a single mistake, a single extra space somewhere in any region name, for example, then you're going to get an X for region names. So the first time you do this, there are probably going to be a lot of issues like this. And here I've combined several models into one file. So then it's just a step through. So for model names, for each of these tabs here, it tells you first, okay, what are the unrecognized names that it found? Okay, what's wrong here? Why GCAM, this looks valid. TM Granton, that looks valid, except there's no version number. If you then wonder, what are the valid names? There's a tab for that here. Okay, so yeah, with Grantham, it's just that Shivika needs to tell me whether she wants to use a hyphen or an underscore. And for Prometheus, yeah, so but also for Prometheus here, it's just the naming the IMC naming convention is that you include the version number without a V. So that's why that one failed. For GCAM, it's just that yeah, so GCAM in the file there are actually some rows have the space, some don't. So that's the reason why that failed. But okay, then we know what we need to correct. Scenario names. Okay, so this is my fault. Because what are the valid names? Okay, these, if you check, these are actually almost identical to what's on here, except that I tacked on the study name at the end. It doesn't know what to do with that. So if you need that, we can add it to the database. If not, then go back and change it. The next two are a bit more interesting. So region names. So region names obviously can be model dependent. So that's why it says here, okay, this name was not recognized. Which model uses this name and for which it was not recognized? Now, this version here only includes the region map for GCAM. That's why all of these other come up. And also there are two invalid regions for GCAM. GCAM doesn't officially have just EU or EU27 region, so that wasn't recognized. I'll add the region maps for Prometheus and TM either tonight or tomorrow, basically. And if you look at all valid names, this is useful to know. So the database here has a region that for each single country with a standardized country name. So that's listed here with the ISO codes. If you go down, you get to the standard aggregated regions, the R5s, R9s, R10s. So it tells you what do those contain and a short description and some notes. And then at the very bottom, you get the model-specific regions. Those are listed as model name, pipe, and then the region code that the model uses. So it has the ones for TM and Prometheus here. It's just that how you map them isn't actually defined. Variable names, there are also some extra things. So there are a bunch of variables here that aren't recognized right now that we need to still resolve. And then for all valid names, there it gives you then the name, the description of the variable, and recognized units for that variable. The latter part is important because you need to validate the units and the unit names as well. So the final tab here on the validation part is variable unit combinations. So there it tells you, okay, for which variables did I find units that aren't recognized for that variable? So here, for example, for capital costs, it doesn't recognize this US dollar sign 2010 because the IMC convention these days wants you to have a 3-letter currency code, an underscore, then the base year. So it didn't recognize that. And right here, it only has 2017. We can add 2010 as a valid base year if you want that. But at the moment, it's just 2017 because that's what the some of the harmonization data uses. Okay, I'll just try to race through here, but the next step is kind of important. That's region mapping. So for those of you not completely familiar with that, all models use different regions. So in order to be able to compare, you need to, in some cases, rename some regions if they use a different name than the standard name, but there is a sort of corresponding standard region. Or if there's no corresponding standard region, then you might need to aggregate regions from the model up until you get to some sort of standardized aggregate region that matches. So doing that renaming and that aggregation, that's referred to as model mapping here. The issue here is that if you use, so the current IAMC tools, the nomenclature package, for example, has tools to do that. One challenge is that it just crashes if you have a single invalid variable or region name. Here, the point here is to like tell you what's wrong, not just that there's something wrong. So you can then check a box here to say that, okay, I want to just bypass any data that has invalid regions or invalid variables, and then those I'll do aggregation on the rest and then combine the results. Then you'll end up with a result that has some parts that are region mapped and some that aren't, which might cause some problems later on, but you can do that. So then you just do that region mapping. That takes a little while. That's easily the most computation intensive step of this entire process. I will add a button here to prepare and download that as an Excel file so that you don't have to do it again. I didn't include it here because of some limitations here. Preparing that Excel file in itself takes a lot of time, so I just didn't want to use time during the demo to prepare that Excel file. Yeah.
If I'm using this and I'm
yeah.
The model registration template where we add the scenario names, we add the model, our model, version, description, and if take that, our model registration file is a valid data for model and scenario.
That's possible. It's not trivial, but it's possible to do that. Yeah. So at the moment, to add variable names, to add region names and model mappings and so on, that has to be updated in this IAM COMPACT nomenclature repository. I can make a procedure for taking what you say a model registration file and creating a new what's called a data structure definition from that, and then use that instead of what comes from the IAM COMPACT nomenclature repository. That is doable. It's just I haven't seen a template that really includes all of the variable names and region mappings in a format that would be suitable for this, but it should be possible. Yeah. 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 So okay, we need to move on, I think, but yes, so one way of doing that is we could do it with an Excel template. There's also, it's quite easy in the underlying structure here to use data that's pulled from another repository. So the common definitions, for example, has like a template for how you can create another GitHub repository of naming conventions and region mappings. And then you can automatically just pull the definitions from a different repository. So that should be relatively easy to do. Taking an Excel template and parsing that would probably be a bit more work, but that should also be possible as long as we have a standardized format that's followed to the T, essentially. Yeah. Yeah, agree. Okay, and then finally, once the region mapping is done, you can proceed to vetting. Actually, you can proceed to vetting even without the region mapping, but you might get some funny results, at least for the harmonization part, because you might then have, model names that collide with standardized region names, but don't mean the same thing, like China in GCAM, for example, which isn't identical to the China in the IMC conventions. But the first screen you get to here is are the AR6 vetting criteria. So you can look at, I should add here a reference to where they're described. But basically this here contains like one row per model and scenario, one column per vetting criterion, and then there's basically a checkbox that tells you whether it passed or failed, and then there's a gray none if your model and scenario didn't have the data to assess that criterion. I think all of the ones here passed with, except for one TM scenario on CCS in 2030. And if you want to see how far off you were, you can go to values here too. I'll add units here so you can see what units these numbers are. That might be useful. But this is basically the indicator used for that vetting criterion, and it tells you what's the number that comes out of your model and scenario for that criterion. And then as long as your number is black, you're fine. If it's red, it's too low. If it's purple, like here for TM, then you're too high. I think the limit here was 3,000 megatons per year. And finally, GDP and population harmonization, and it computes a little bit, and then it tells you, okay, so here for each variable here, GDP or population, is it in range, yes or no? And in range here, I just arbitrarily set that it should be plus minus 2%. For other variables, maybe it should be a bit broader than that. And it tells you how much too high or too low is it. And here, just to be aware of here, you'll see here that GCAM has some regions which are wildly out of range. And the problem there isn't actually the numbers, but sorry, GCAM, the problem is you gave me a faulty region mapping file. So that's, I see now that that's been corrected. So probably if I update with a new region map that's in the nomenclature repository, that should now go away. But just to be aware that if you're like okay at the world level, but some regions are just crazy, then probably there's something wrong with the region mapping and not necessarily your numbers. Okay, that's basically it. So emissions will also be added here soon, and energy